Hi, welcome to the Shikon Mathematical Statistics lecture series. And here is the problem we are going to work today. And so in here, we're going to examine the relations of the sample standard deviation and the sample means here. Okay, so let's take a look. What do we have here? So we say x1, x2 to the xn. And so the n's here is 10. From a sample from the normal distributions, it's 0 and the sigma square. So let's define the coefficient of the variation CV, and it's defined as S over X bars here. So I want to take a look, what is the distribution of the 10 the X bar square over S square? And what is the distributions for the S square over the 10 the X bar square? Just flip it. The reason why here is 10 is because my sample size is 10. And then if there is a function C such that the coefficient of the variation CV is between C and negative C is equal to 0.95, then what is the C? The reason I choose this problem to work on today is because in order to work on this problem, is kind of we need to know a lot of the basic sampling distributions here. And I thought it's a good combination of the knowledge for the, what we learned before and how to apply to here. All right, so so now the first thing is let's go ahead get started here. Okay, so let's go to the whiteboard here. Okay, here is the whiteboard section. Okay, so so let's get started here. All right, so the first things here, the part A, we want to prove is what is the distributions of the 10 X bar square and S squares here. Okay, so in order to prove it, like I mentioned before, the reason why this is a pretty good problem because we need to use a lot of other sampling distribution properties here. Okay, in order to do that, the first thing is let's take a look at what the properties I have here. So right now here I have x1, x2 to x10s, right? So these ones they are from, it's a sample of a sample size 10 is from a normal distribution of the 0 and the sigma square. So the first things we know, the x bar here will be what? The x bar will be the normal distribution. And what is the sigmas here? Will be sigma square over n's here, right? So if this is my x bar, then I know that x bar minus 0 over the sigma over square root of n. So what is this? This is a z distributions, right? So what is a z distribution? So the z distribution is a what? It's a normal distribution with 0 and 1. It's a standardized distribution. So this is the first property, we need to know here. Okay, so then the next property is also when we talk about the sampling distribution is a very, very common distributions here. We said for the samples variances. So we know the n minus 1, the s square over sigma square. So we have proved this before. We said this will be the chi-square n minus 1. Right? So this is a chi-square distribution of the n-1. So those are the two very fundamental before we applied these ones here. Okay, so the another sampling distribution we need to be aware of is how do we define the t distributions? Okay, so the t distribution, the way we define the t is what? We said the t is the z, so it's a standardized normal, and over, we said v, so we will say that this is the t distribution and v over what? V over k. So we know the z, this is what? Is the normal 0, 1. And the v, what is this one's here? This one is a chi-square with degrees freedom is k. Then the t distribution is z over the square roots of the chi-square divided by the degrees freedom. Then this is, we said, this is a t distribution with a what? This is a t distribution with a degrees freedom is a what? It's a k. All right, so this is the third sampling. Then we have another good ones here. So we said, okay, how about if I square the t distributions here, right? So we also prove that. So if I square this t distribution, we know it will become the f distribution with what is the degrees of the freedom? With the degrees freedom 1 and what? With the degrees freedom 1 and the k here. Correct? And then the last, last things we're going to use here, it will be if you put the 1 over f of the 1 and the k. So we know if you flip it, what this one will be? This will be the f distribution with a k. 1. So you just flip the numerator and the denominator, degrees freedom. So that is why this is good questions to work on. Why is that? Because we have a few, we have how many the sampling distribution property we need to be aware of. This is the first one. This is the second one. We need to know how do you define the t distribution. We need to know when you square the t distribution, what is it going to be. We need to know if you flip the f distribution. So it is a very good kind of the review problem, summary problem about what you learned from the sampling distributions here. Okay, so now let's take a look here, all right? So I know the x bar minus 0 sigma over square root of the n, right? Okay. So now let's take a look here. So now I know the x bar minus 0, right? Over the sigma. So here, the sigma here over square root of n. So over what? Over 10, right? So this one will be the z normal 1, right? So this will be z, and so this will be the normal distribution 0, 1. And also we know, right? So let's put these ones here. So we know n minus 1 s square sigma square, right? So that if I divide by the degrees, so this is the chi-squares, right? So this is the chi-square with the what? With the degrees freedom, what? So n minus 1 here. Okay, so now I want to combine these two. So take a look here. So this is x bar minus 0, and this is sigma over square root of 10. And this one's n minus 1 will be what? Will be 9, right? So it's 9s squared. Okay, so now I have 9s squared over sigma squared, right? This is a chi-square, and then divided by the degrees freedom, right? So we know if you divide by degrees freedom, divided by degrees freedom 9, and the square roots of that. So what happened here? This will be my t distribution with how many degrees freedom? 9 degrees freedom, right? Okay, so now if you do a little bit of simplifications, so you can see here. So you will see here, this is x bar, right? Minus 0 just be the self, sigma over square root of n 10. So you flip that square root of 10 here. Then the buttons here, right? So 9 and 9 cancel. And then the sigma here. So it's you flip the sigma to the top, and the s squared, take the square root, it's s, right? So here and here cancel. So I can come to the conclusion, the square root of the 10 x bar s squared is equal to what? Is t. So it will be the t distributions, right? So it will be t distribution with the degrees freedom is 9. So now, okay, so now they want 10x squared. So if I square both, so if I square this, right? So if I square this, then I will get is a 10 x bar square s square what we just talk about, if you square the t, will be what? So will be the F distribution with 1, and the degrees freedom is what? Degrees freedom is 9. Okay, so this is what we show in the part A here. So the part B, they say, what is the distribution if you flip it? Okay, so that's easy. So if you flip it, so it's 10 to the x bar square. Because the 10, the x bar square over s square is F distribution. So what is this one going to be? This one going to be F distribution with 9 and 1 here. Right, so it's pretty straightforward. Okay, so now the part C, the last part, they ask us, hey, try to find the value of the C's here. So you can say this is the S over X bar from the C to C, right? From the positive C to negative C, this is equal to the 0.95. So what is the C values here? Okay, so now we can do this. We say this is a probability. So basically this is just the absolute value of the SX bar less than C, right? Okay, then you square. So this is a probability. So this is S square, X bar square less than equal to C squares, right? Okay, so it's less than equal to C squared. Let me get rid of some of this so I can have a space to write it. Okay, so now this is now we know from the part A, if this S squared over 10 over X bar squared is F distribution. So what I can do is here, I can times the 1 over 10 both sides, right? So I put a 1 over 10 here, X bar squared here. So this will be the C squared over what? C squared over 10 here, right? So I know this one is equal to what is 0.95. Then you can, and now in here, we just proved what is this function here? This is the F distribution with what? This is the F distribution with degrees freedom 9 and 1. So you can either use the the existing F distribution table and to find what is the value, give you 0.95, or you can put it into the calculator to get it. So if we use the table, I can find the C squared over 10 is equal to what? It's 240.5. Or you can use the calculator to find it. So C squared. So that's why I can find the C is equal to what value? It's 49.804. Okay, so that is what is our values here for the part C here. All right, so that's it for this problem. Like I said, this is a very good problem. It's not too hard, but we use basically most 5 most important the sampling distribution properties here. All right, hope this help and hope you enjoyed it. Okay, and like we'll talk to you in our next topics here. Okay, bye.